Hi guys, Liva here from Bright Young Brains. In this video, we need to prove this identity. So this question is specifically from the 2024 May-June exam, which was written not so long ago as of this recording, and it was question number 5.3.2 if I'm not mistaken, 5.2 actually. So we had to prove this identity. The one thing that stood out for me with this identity is the fact that it does look fairly simple, but I remember once I actually started working on it, it wasn't as simple as it looked to be. But anyways, the one thing that you want to take into consideration is that between the left hand side and the right hand side, the right hand side definitely does look a bit more complicated than the left. Furthermore, the right hand side, we can see that we have a fraction and the denominator is cos x. This left hand side has 10x somewhere. And what we do know about 10x is that 10x can be written as sin x over cos x. So this cos x as the denominator there, it looks as though it might eventually help us to end up with something that looks like this. So since I've already gone through this question, to summarize, the first thing that you do want to do, that you should not be afraid of doing, is multiplying out these two brackets over here. So since we've decided to work on the right hand side, you can just communicate with your examiner by telling them that you are working with the right hand side. Looking at the right hand side, the first thing you can do, we don't have to rewrite it, we can just multiply out the brackets. So multiplying out the brackets, you can have sin x multiplied by 1, which is sin x, and then sin x multiplied by sin x cos x. That's going to give you sin squared x cos x. There we go. Furthermore, cos x times 1 just gives us a cos x. And then lastly, cos x multiplied by the sin x cos x is just sin x cos squared x. There we go. In the exam, this was a 5-mark question. They were giving you 5 marks for this question. Rule of thumb, 5-mark questions should not take you longer than 5 minutes. So from here, we should not forget our denominator, which is cos x. Fortunately, you are able to put each of these terms with cos x as your denominator. We don't have any like terms at the top, so you don't have to simplify. You cannot simplify any further. So writing each individual term with cos x as the denominator, this is what we have. There we go. So as you can see, fortunately each term is under the same denominator. Now looking at what we want to work towards, we can easily see that this is where our 10x is going to come from. However, what you want to do when you come across questions like these, you want to think to yourself, okay, fine, how will I eventually have cos x? Well, how will I eventually have 10x with the open bracket and then 1 minus cos squared x in there? You can almost think of it as a scenario where 10x was taken out as a common factor between these two. The reason why you may want to think that way is because this expression, the way it looks, it's quite a lot to think about. So if you're eventually going to have 10x with an open bracket and 1 minus cos squared x in there somewhere, you want to think of a scenario where you at least have 10x twice in this expression. That's what you want to think of. So for us to eventually at least have 10x twice in this expression, we fortunately have actually one scenario over here and another scenario over there where we can have 10x somewhere, and here also. So let's see how many times we can actually have 10x in this expression while it is actually necessary. So this we can change it to 10x. Let's maybe change that to 10x. This on the other end, coincidentally, here you might find yourself in a bit of a predicament, because this you can change it to sin x over cos x. That's going to give you 10x. However, the issue is that at the top you will still be left with sin x somewhere. What I mean is this here, right? you can rewrite it as one single sine x at the top over the cos x here. That will become 10x. However, one sine x at the top will still be remaining, and then one cos x at the top will still be remaining. So you would think to yourself, okay, fine, if I change this to that, is that really making life easier? So you can maybe then ask yourself, what if I were to change this one to something that is 10x? If you change this to something that is 10x, you're going to have sine x over cos x, which is going to give you 10x, yes. However, fortunately, with this expression here, you will only be multiplying the 10x with cos squared x. And looking at you ending up with something like this by changing this, or ending up with something like this by changing this, you can easily see that this may actually be the better option, because you can see that somewhere along the lines there is a cos squared x somewhere. So you can see that these two, right, they can work together to eventually end up with an expression like this, as opposed to you working with this and this, or all three of them together. Okay, so to summarize this here, we can easily maybe just cancel the cos x here and the cos x there. This is going to give us negative sine squared x. Here, cos x over cos x, that's just a 1. And then this is what we can change to 10x. So with our expression looking like this, fortunately, we can already see that from this to that, it doesn't look like we have a lot to worry about. The one thing that you can think to yourself is, okay, fine, the 10x here and the 10x there, these two, we can easily have those as somewhat of a common factor. But then the sine squared x plus 1, obviously, looking at the way this looks and looking at what we have here, the sine x squared plus 1, you can maybe rewrite that swapped around, so that you can easily see that you just have 1 minus sine squared x. This should remind you of your square identity. Remember, the square identity basically states that sine squared x plus cos squared x, this is equal to a 1. If you were to take the sine to the other side, you would have cos squared x is equal to 1 minus sine squared x, like that. So this, we can replace it with just cos squared x. So we're going to have here 10x. There we go. So let's just maybe group these two together and take out a common factor and see what we end up with. Yeah, let's see what we end up with. Okay, so at this point we're very close. We're actually kind of done, because the whole time I'm looking at this expression only, I'm forgetting there's a cos squared x there. So this cos squared x, we can easily just say that's the cos squared x here. Here we take out 10x as a common factor. There you go. And then you can easily then say, therefore, the left hand side is equal to the right hand side. You've proven that the left hand side is definitely equal to the right hand side. All this that we did here, as we have already stated, this should have taken you less than 5 minutes. So key pieces of information here, it was just the square identity and also just basic trigonometry from grade 11 actually, and possibly also grade 10. So that's that for this tutorial. For more tutorials like this, don't forget to subscribe. If this was helpful, smash the thumbs up button, and I'll catch you in the next tutorial.